Hello, Accelerated Math 7-8 students. We are going to be working on our 7th video. And our 7th video for today is called Multiplication and Division of Rational Numbers. I'm hoping that you're starting to see a theme in what we've been working on. So multiplication and division of rational numbers is found on page 21 in my comp book. So I'm going to turn there now. And this is what it looks like. Okay, so lesson for today, multiplication and division of rational numbers. The goal, today we are going to practice the rules and tools for multiplying and dividing rational numbers. Let me fix that. That says ration numbers, so let's change it to rational numbers. Thank you for that. That's me writing way too fast. Okay, the question that I want you to be thinking about today is, what is your favorite tool to use when multiplying or dividing rational numbers, and you need to explain why. Okay, you're going to learn. You've been learning a ton of tools. Your job now is to really focus on them and decide which ones that you like the best, and then use them. Okay, so let's take a look at what we've been working on for a little while, because what we've been working on is building up to what you're going to be doing today. So we're going to look at this one first. And one of the things that you have to be able to do is you have to be able to take any rational number and multiply it by something. So we call that the rational number multiplication. Okay? This right here is a rational number because it is a decimal, and it happens to be a negative decimal. And negative decimals exist. If you think about a number line and you go below 0, you can have parts of a number. You can have 2.5. You can have 3.5. You can have negative 8 and 6/4. You can have all kinds of parts of numbers on the negative side of the number line, as well as the positive side. So negative 2.5 does exist. It is considered a rational number. So what we need to do is we need to take negative 2.5, multiply it by 4. Okay? And so basically what that means is you're taking negative 2.5 and adding it 4 times. And the reason we know that is because multiplication is the same thing as repeated addition. So as long as you can remember that little thing, making this part will be a lot easier. So one thing that we need to look at is when you're multiplying or timesing, that's the other word we know for multiplication, you need to remember that a negative times a positive is a negative. Okay? But if you're changing this problem from a multiplication problem into repeated addition, you need to remember this. A negative plus a negative is always a negative. Either way, what do you notice? The answer is going to come out as a negative. Okay? And that's what proves that these rules work and that they're consistent. So I would like to show you either way. If you decide that this problem is truly repeated addition, what you're going to do is you're going to take negative 2.5 plus negative 2.5 plus negative 2.5 plus negative 2.5. So a negative plus a negative plus a negative plus a negative is always going to be a negative. Well, very quickly, mental math tells us that 2.5 plus 2.5 is 5. 250 plus 250 is $5. So 250 plus 250 is $5. So I have $5 here and $5 here. That gives me a total of $10. That was mental math. And we know that the answer is going to be negative. Or we could also do the multiplication, which is very simple. You set up a multiplication problem. So you have negative 2.5 4 times, or times 4. So 5 times 4 is 20. Regroup the 2. 4 times 2 is 8, plus 2 is 10. Remember your placeholder is 0, and you know that a negative times a positive is a negative, so you put your negative down there, and you know that negative 2.5 times 4 is negative 10. Okay? So I think the thing that we need to be very, very cognizant of in this lesson is that rational number multiplication is just like integer multiplication. You have to remember your rules. A negative times a positive is always a negative. A positive times a positive is always a positive. A negative times a negative is always a positive. And so it's just really trying to get those rules identified and known in your brain so that you can use them. Okay? All right, moving on to the next one. Rational number division. Okay? So we're going to look at it again from the division side. and we're going to use all of the information that we've learned so far. So this one says rational number division, and the problem that I want you to try is negative 10 divided by 2.5. Now you're going, well, didn't we just do that up above? Well, we did, but I want you to see the similarities, okay? So we have negative 10 divided by 2.5. Negative 10 divided by 2.5. So again, we need to think about our rules that we've been learning. A negative divided by a positive is always a negative, okay? I also want you to think about the idea that division is also repeated subtraction, so you could remember that as well. And if you do that, you already know a subtraction problem is the same thing as adding the opposite. So boys and girls, do you see how many different things that we have learned already that you just have to start using, okay? I don't care which way you go. You can either divide it out or you can use subtraction, which is the same as adding the opposite. In the example, I showed subtraction is the same thing as the opposite. So I wrote it out. Negative 10 minus a negative 2.5. And the reason why we had to write negative 2.5 in parentheses is if you're starting with a negative and you're taking something away, what is the value of what you're taking away if it's negative? It's negative. You can't have a negative number and then try to take part of it away and make it a positive, because that's changing the value. So what you have to think about is I have 10 negatives. I'm taking some of that away. So when I'm taking it away, I'm taking the negative away. And then showing takeaway is what we put in the middle. So this is the operation sign, this is the value sign, and that's what can get really tricky. So we have negative 10, subtract a negative 2.5, subtract a negative 2.5, subtract a negative 2.5, subtract a negative 2.5. And then I remembered this rule. Oh, well, a subtraction problem is the same as adding the opposite. So what is the opposite of a negative 2.5? It's a positive. So here we go. We have negative 10 plus the opposite of a negative 2.5. So we did 2.5. So negative 10 plus 2.5 is negative 7.5. Does everybody see that? Then you have negative 7.5 right here, and we add the opposite, so we're adding 2.5, and we get negative 5. Okay, so now we have negative 5, we add the opposite, so we're adding 2.5, and we get negative 2.5. Now this part right here, which you cannot even see, so I'm going to try to get it so you can see it, that is the most pivotal point, because look at what we've done. We've actually subtracted it out so far that we are now on 0. Check it out. So negative 10 plus 2.5 is negative 7.5 plus 2.5 is negative 5 plus 2.5 gave me a negative 2.5. And then we add the opposite of 2.5. Well, look, a negative 2.5 plus a positive 2.5 gives me a 0 pair. That's correct. So you've divided it out to 0 being the only number left. So the question is, for this division problem, how many times did we subtract 2.5? When you tell me how many times we subtracted 2.5, that's going to be your answer. Okay? So count them. How many times did you do it? 1, 2, 3, 4. We did it 4 times. So what does the answer to this problem have to be? Remember, we're subtracting. We're taking it away. So what does the sign have to be? Negative, how many times? 1, 2, 3, 4. So what is the answer to this problem? Negative 10 divided by 2.5 is negative 4, because we took away 2.5 4 times. A negative divided by a positive is a negative. So negative 10 divided by 2.5 is a negative 4. Okay? Boys and girls, do you all see that? I hope. One of the things that we need to get very, very comfortable with, and I don't think you're there yet, and so that's why we're going to continue to practice it, is we have to realize that whenever you're multiplying or dividing rational numbers with different signs, you use the exact same rules as multiplying and dividing integers with different signs. So we're going to look at this next page, and we're going to remember a little tool. Okay? Now, if you're in 8th hour, I did tell you about this tool. If you're in 9th hour, we ran out of time. So I would like to introduce this tool formally to everyone. Now that you can prove why the rules work the way that they do with the chip model, and you guys can do it, you've shown me this multiple times, I am now going to give you a tool that you can use for speed, okay? Because I'm feeling pretty confident that you understand why the values will come out negative or positive, but drawing chips for every problem is cumbersome. It's a nightmare. You are going to be saying my name in vain if I make you write the chips for every problem you come across. So here is the best news ever. You do not have to use the chips for everything now because I'm feeling pretty confident that you understand it. But you may find a spot where you just can't really remember. And so there's a tool, it's called the helpful triangle, that helps you understand and remember how it works. So the thing that we discussed in some of the classes is kids were noticing that whenever we were working with something, there were always two negatives somewhere, unless you're doing a positive times a positive or a positive divided by a positive. That is just a positive always because you have no other option. But when you have a negative and a positive, there's always another negative somewhere. So this triangle has to be drawn exactly like this. If you draw it any other way, it won't work. So you draw a triangle, the plus goes in the top always, the negatives go along the bottom always, okay? So there's the little triangle. Now here's the coolest thing. This is how it works. So the triangle is a tool, again, something for you to use, but here's the situation. A positive times or divided by a positive is always positive. You know that. We've already established that, clear back in 3rd grade. But in sign numbers, here's something new that we're learning right now. A negative, so you cover it up, or times or divided, it doesn't matter which operation times or divided. Oh, by the way, this triangle only works for multiplication and division. Did you hear what I just said? This triangle only works if you're multiplying or dividing. So a negative, cover it up, times or divided by a negative is positive because that's what you see. Okay? So the answer is going to be whatever is not covered up. That's how you use this tool. Let's try another one. A negative times or divided by a positive is going to have an answer that is, that's right, a negative, because that's what's showing. Okay? One more. A positive times or divided by a negative, and look what showed up, a negative. So your answer would be negative. Does everybody understand how this tool works? Okay? Again, this is a tool to help you organize what you already know. And these rules are crucial, kiddos. You have to remember these rules. And so we could even call this a graphic organizer because it's a way for you to organize your thoughts to remember these rules. Okay? So hopefully you guys will like the helpful triangle. All right, the other thing that I want to share with you or remind you of when you are multiplying and dividing rational numbers, another tool that can be very helpful are the properties. Okay, and the thing you have to remember about properties allow you to change the order, that's the commutative, as long as you're adding or multiplying, grouping, as long as you're adding or multiplying, or there's properties that deal with quantities. And what we're going to talk about with that one is the properties of dealing with quantities is there's a property that allows you to multiply it by a reciprocal, and that gives you a change in your quantity. So the properties allow you to change order, grouping, or quantities, making the problems easier to manage. Okay? So one that I want to go over really quickly because I think you're pretty solid with the commutative, and I know you're pretty solid with the associative. The associative is when you get to change your groups with your parentheses, is this quantities idea. So the thing that I want you to know is division is the same as multiplying by the reciprocal. Okay? Now some of you are going, okay, I know a reciprocal is when you take the denominator and the numerator and you flip them, right? So that's the reciprocal. And so when you do that, you're actually making your division problem into a multiplication problem. And I'll show you how this works. So let's say that the problem that we want to work on is 12 divided by a negative 2/3 times 2 divided by a negative 9 times a negative 5 divided by a half. Okay? So now, this is a huge expression, and yes, you're going to have to do these problems. So now you can see why I'm trying to give you some tools to help guide you. So the first thing that I want you to focus on in this problem is we're going to do it by chunks. So we always start, because of order of operations in math, we always work left to right. So we're going to start on the left and move to the right. So the first thing that I want to do is I need both of these to be a fraction in order for them to work. So I make 12 into a fraction without changing its value, giving it a numerator of 1. So 12 is the same thing as 12 divided by 1, or 12 once, okay? Then I remembered what Mrs. Nelson said, that division is the same as multiplying by the reciprocal. Well, if I look at this fraction right here, the negative has to stay because it's negative, okay? The reciprocal doesn't have anything to do with that negative. When you're working with reciprocals, you're only looking at the actual fraction. So this fraction says negative 2/3, okay? So the reciprocal of negative 2/3 would be negative 3/2, because all I did is I replaced the denominator and the numerator with each other, and I performed the reciprocal. So division is the same as multiplying by the reciprocal. So now I have 12 once times negative 3/2, okay? Now I'm actually going to solve that. So if I solve it, I get 12 times a negative 3, which is a negative 36. 1 times 2 is 2. Negative 36 divided by 2 is negative 18. Okay? And then I just bring down the rest of the problem above. So I have negative 18 times a positive 2 divided by a negative 9 times a negative 5 divided by 1/2. Okay? Well, that's pretty simple, because now I just have to combine like terms. And my like terms on this line are whole numbers. Whole number, whole number, whole number, whole number. Well, sorry. Integer, 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 integer. These aren't wholes because they're negative, so I had to change my language. Sorry. These are actually integers. They're whole number integers. So we have negative 18 times 2 divided by a negative 9 times a negative 5, and this one now becomes a rational number because it's a fraction. But we can deal with that. Okay, so let's look at it. First, combine from left to right. So negative 18 times 2 is negative 36. Combine left to right. A negative times a negative is a positive, and 9 times 5 is 45. Does everybody see what I just did? So now I have negative 36, bring down my division sign, multiply the whole numbers and got 45, bring down the division sign, 1/2. Okay? Hopefully you guys are understanding how I combined my like terms. Okay, the next part is, and let me zoom out a little bit so you can see, sorry, is let's rewrite this so we understand it. Negative 36 divided by 45. Can it be written like this? Same exact problem. Read it. Negative 36 divided by 45. Those are exactly the same. So what we like to do is take negative 36 45ths divided by 1/2, because all I did was bring down the division sign and bring down the half. Okay? And then this is really easy to go, because I remember my new rule that I'm learning, that division is the same as multiplying, sorry, I'm going the wrong way, multiplying by the reciprocal. So the reciprocal of 1/2 is 2. So now I have negative 36 45ths times 2. So negative 36 times 2 is 72, and it's negative. 45 times 1 is 45. And now my job, my last step, which you can't see because I zoomed it in too big, let me go the other way, sorry, is find a number that goes into both of them to simplify. So negative 72 divided by 9 is negative 8. 45 divided by 9 is 5. So the answer would be negative 8/5. Do I want you to take it any further? The answer is no. You're done. That is the answer. Now, kiddos, remember that we have been working on or learning about multiplication and division of rational numbers. What you just did is exactly that. So let's go back to our question of our lesson. And the question of this lesson was, what is your favorite tool to use when multiplying or dividing rational numbers? explain why. Boys and girls, the tool can be any of these, all right? And one other thing, kind of a commercial message. This triangle can be used with rational numbers, but it also works with integers, okay? So, I don't know. I'm not going to tell you what my favorite tool is because I want to know what your favorite tool is, and I would love to hear it. So, in the morning, what I would like to know, did I leave anything for you to do? No, I didn't. Okay, so the only thing I'm going to be looking for in the morning is your favorite tool. Make sure you know what it is and make sure you have it written because you have to explain why. All right? All right, my dears, that's it. That's the end of the lesson. Have a good one. See ya.